Article 220.87b of the National Electrical Code addresses the use of previous electrical bills for calculating electrical service requirements. This provision allows for a more accurate assessment of actual load demands rather than relying solely on calculated loads based on connected equipment. To effectively utilize this method, it's crucial to understand the specific conditions and limitations outlined in the code. Firstly, the available billing data should cover a sufficient period, typically at least 1 year. This ensures that seasonal variations in electrical demand are accounted for. The billing data should reflect the actual usage patterns of the existing electrical installation. Secondly, the code specifies that the calculated load must be adjusted to reflect any known changes in the electrical system. This includes the addition or removal of significant loads. For example, if a large motor has been disconnected or a new air conditioning unit has been installed, the billing data must be modified accordingly. Thirdly, the determination of the maximum demand from the billing data requires careful analysis. This involves identifying the highest kilowatt or kilovolt ampere demand recorded during the billing period. The code may provide guidance on how to smooth out short-term fluctuations in demand to arrive at a more representative value. It's important to consult the specific wording of Article 220.87b in the relevant edition of the National Electrical Code for precise requirements. Fourthly, using previous billing data is often applicable in situations where an existing building is undergoing renovations or expansions. In these cases, the historical data provides a valuable insight into the actual electrical consumption of the building. This allows for a more accurate determination of the additional capacity needed to accommodate the new loads. Fifthly, remember that the authority having jurisdiction, also known as the AHJ, has the final say in approving the use of billing data for service calculations. It's advisable to consult with the AHJ early in the design process to ensure that the proposed approach is acceptable. Sixthly, the NEC emphasizes the importance of safety in electrical installations. Therefore, even when using billing data, it's essential to ensure that the electrical system is adequately sized to handle potential future loads. This may involve adding a safety factor to the calculated demand. Seventhly, it is important to differentiate between demand factor and diversity factor. The demand factor is the ratio of the maximum demand of a system or part of a system to the total connected load of the system or of the part of the system under consideration. The diversity factor is the ratio of the sum of the individual maximum demands of the various subdivisions of a system to the maximum demand of the entire system. Eighthly, beware of any limitations or restrictions imposed by the local utility company. The utility may have specific requirements for the type of billing data that can be used or the method of calculating demand. Ninthly, Article 220.87b typically requires that the billing data be obtained from a reliable source. This usually means obtaining the data directly from the utility company. It's important to ensure that the data is accurate and complete. Tenthly, when using billing data, it's essential to consider the impact of power factor. A low power factor can result in a higher current draw, which can affect the sizing of electrical equipment. If the billing data does not include power factor information, it may be necessary to make adjustments to the calculated demand. 11thly, understand that using billing data for service calculations is just one of several methods available in the National Electrical Code. The code also provides detailed guidelines for calculating loads based on the type and size of connected equipment. It's important to choose the method that is most appropriate for the specific situation. 12thly, remember that the National Electrical Code is a minimum standard. It's always advisable to exceed the minimum requirements when possible to ensure the safety and reliability of the electrical system. 13thly, consult with a qualified electrical engineer or contractor for assistance with service calculations. They can help you interpret the code and apply it to your specific project. They can also help you identify any potential problems or issues with your electrical system. 14thly, carefully document all calculations and assumptions made when using billing data for service calculations. This documentation will be helpful for future reference and for demonstrating compliance with the National Electrical Code. 15thly, ensure that the electrical system is properly grounded and bonded. Grounding and bonding are essential for protecting against electrical shock and fire hazards. 16thly, use appropriate overcurrent protection devices to protect the electrical system from overload and short-circuit conditions. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. 17thly, install surge protection devices to protect sensitive electronic equipment from voltage surges. Voltage surges can damage or destroy electronic equipment. Surge protection devices divert excess voltage to ground, protecting the equipment. 18thly, use appropriately sized conductors for all electrical circuits. The size of the conductors must be sufficient to carry the maximum expected current without overheating. The National Electrical Code provides tables for determining the appropriate conductor size for various applications. 19thly, properly label all electrical panels and circuits. Labeling helps to identify the purpose of each circuit and makes it easier to troubleshoot electrical problems. 20thly, regularly inspect the electrical system for any signs of damage or deterioration. Regular inspections can help to identify potential problems before they become serious. 21stly, keep the electrical system clean and free from debris. Dust and debris can accumulate on electrical equipment and cause it to overheat. 22ndly, ensure that all electrical work is performed by a qualified and licensed electrician. Electrical work can be dangerous and should only be performed by someone who is properly trained and experienced. 23rdly, obtain all necessary permits before starting any electrical work. Permits ensure that the work is performed in compliance with the National Electrical Code and local regulations. 24thly, follow all safety precautions when working with electricity. Electricity can be deadly if handled improperly. Always turn off the power before working on any electrical circuit. 25thly, if you are not comfortable working with electricity, do not attempt to do it yourself. Hire a qualified electrician to perform the work.